Solving radical equations. We'll do, this is a two-part section. We'll do half of it today and half of it tomorrow. Radical equations, remember what a radical is. It can be a square root. If there's nothing there, it's a square. It could be a cube root. Any number could be on the outside. So before we start solving, tell me what, if you encountered this in an equation, what cancels it out? How would you get rid of it? Raise it to a power. What power? The same power. Whatever this is, that power will cancel it out. Ah. Are we all in agreement on that? Pretty easy. So as we solve these, what we're going to do is we're going to isolate the radical, and then we're going to get rid of the radical. I know some of you like steps, so I'm going to give you 3 steps here. Now isolate the radical, get rid of the radical, and solve. And this is whenever you only see one radical in your equation. Now, as y'all copy that, tell me what does isolate mean?
By itself.
Get by itself, okay? So we don't want to do anything under the radical before we get that radical by itself. And sometimes it'll already be by itself, and sometimes it won't. Start easy, work our way up. So let me start with an easy one. Let's say I have the cubed root of 2x plus 7 equals 3. One radical, so my question is that radical isolated?
No.
Is it by itself?
Yes.
I hear yes and no. Do I have a radical, and it includes everything under the radical, but is one side only a radical?
Yes.
Yes, right? Do we see that? So everything else is away from it. So that step 1 is done. It's isolated. Isolated. Check. So now I want to get rid of the radical. So you told me to get rid of a radical that has a power of 3. I do what? I'm in a root of 3.
To the third power.
Third power.
What?
What I do to one side, I have to do to the other. Okay? This exponent cancels this out. So it's gone. Don't take it inside the radical. You're going to make your life so hard. Leave it just like that. It cancels, so now I have 2x 27, exactly. Can you solve that now?
Yes.
Yeah. It's a simple linear equation. Does that confuse anybody?
Yeah.
All right, let's make it a little bit harder then. Let's say I have 2 times the third root of x minus 3 equals 4. Is my radical isolated?
No, it has.
No, it's got a 2 in front, so you're right. I need to divide by 2 and get rid of it. Now, when you do that, don't mess with anything under that radical, okay? Leave it.
Is that a whole new problem?
This is a new problem, a new example. Is the radical isolated? Yep. Y'all are both right. Andrew, that's right. Jordan. Raise it to the third power because that gets rid of that radical. What?
How you get 2/3? I don't want to repeat 5.
I forgot.
Hey.
I add 3, and you're right, it's 11. Now, these have been really easy so far. What if, and you do have one like this on your test. No, a little bit, no. Make sure you write this one down and start in your notes.
It's the same one from the test?
Very similar. As I look at this one, probably Thursday,
What?
maybe Wednesday, I don't know.
Yeah.
Wednesday or Thursday. All right. So, yes. Does everyone agree at this point that the radical is isolated?
Yes.
Yes, because it's on a side by itself, so I got to get rid of it. So Jordan's right, I do have to square to get rid of it.
By 2?
Now, by 2, that's right, Brady, but whenever I square it, if I do this side, I have to do this side, but I have to do this whole side. Okay? Which means this is gone, but look at this side over here. You're going to have to, you can't distribute because of the plus in the middle. This becomes a FOIL problem.
How did you get that 2?
The 2 means write it twice.
How did you get?
Because, see the pink? This was a square root, right? Which means there's an imaginary 2. I have to get rid of it. So to get rid of it, I raise it to the second power. And now I'm going to FOIL the left side.
Hold up.
Okay. All right. So I take x times x is what?
X squared.
X squared. X times 1.
Is 1x. 1x.
1x, or 1 times x.
1x.
And 1 times 1. So let's clean up the left a little bit, combine the like terms. That's right. X squared plus 2x plus 1. We just added those two 1x's in the middle. Now I have a problem. Yes. I have a quadratic. Before I can ever solve a quadratic, I got to rewind back to chapter 1, because that's when we solved quadratics. I need to make it equal 0. Okay? So, yes, I'm going to combine like terms, and to combine like terms, I'm going to move everybody to the same side. So I'm going to move the 7x and the 15. Yep. Because what I want to do is I want to make this side equal 0. So that I have x squared minus 5x minus 15.
And if it equals 0, it's still.
Now think back.
That's all.
How do you solve a quadratic equal to 0? Yes, Sadie. Good job. Put it in the box.
Go, girl.
The factoring box. We factor it. Anytime you get a quadratic, what is a quadratic again? Come on, guys.
Anything that equals 0?
It has an x squared term, okay? See the x squared term there?
Yeah.
If you ever get a quadratic, make sure you make it equal 0 and then factor. If you can't factor, what can you do? Ooh, y'all got a final exam coming up, and this is chapter 1.
What you do is, we're going to why?
Quadratic formula.
What's factor? No, what's a factor? Is that the box?
Yes, that's the
What's
box.
quadratic form?
So for this one, I can factor it. This is a quadratic. It's already equal to 0.
How do you know it's box? In the box, it is
Yeah, with the signs that are on the board behind you. This is going to be mixed signs. What two things multiply to negative 14x squared but add to negative 5? Negative 7 and positive 2.
I hate that. I think
It is the foundation of Algebra 2, though. Everything comes back to that. Yeah, they gotta have an X. All right, let's go up. What's the GCF here? And how about here? How about here? Y'all are saying it just not confidently.
11.
But this is going to be negative since they're both negative.
Yep.
That's all I know. X plus 2 and X plus
So tell me this. What was the point in factoring?
So 1x. What it is, right?
What did I initially want to do? I'm trying to do what? Solve it for x. I want to know what x equals. I have two sets of parentheses being multiplied together to give me 0. Tell me what you know about one or both of those sets of parentheses. Yes, that's right. This is where we separate them. So we say x plus 2 equals 0, x minus 7 equals 0. Which means x is negative 2 or x is 7.